So I said there are over 20. However, the one that is used currently is Landsteiner's grouping system. Landsteiner's grouping system. So Landsteiner's grouping system. So it was Karl Landstein. He's an Austrian scientist. So Landsteiner's grouping system. That is what we currently use. I hope you guys are jotting these things I'm saying. Now there are two systems as postulated by Landsteiner. The first is the ABO grouping and the other one is the rhesus grouping. The ABO grouping and the other one, I said there are two blood grouping systems as postulated by Landsteiner. I said the first is ABO grouping and the second is rhesus grouping. ABO grouping and the second is rhesus grouping. Now, as I said, if you knew your blood group, you will be telling me that your blood group is A, O, B, O, A, B, or O, O. This one now is on the basis of your ABO grouping. But when you now start hearing I am A positive, or you hear I am A negative, or you hear I am B positive, or I am B negative, this negative and positive here is where the rhesus grouping comes into place. Sorry, I hope you guys are following me. Biology students. Now, the major reason we are discussing this is to describe and understand agglutination. So I'm not going to overemphasize some things. The most important thing you need to understand from this is in what combination or under what blood transfusion will agglutination occur. Once you're able to understand that majorly, and then finally your rhesus factor, we should be good with that basically. So let's start with the ABO grouping. So you write the ABO grouping. Can you still hear me? Wow. Can you guys still hear me? Can you still hear me? Can you guys hear me?
It's breaking a little bit, but I can hear you better now.
Okay, so I said, let's get to that. So I said the ABO grouping is a grouping system dependent on antigens. Dependent on antigens. Antigens A and B. So the two antigens that determines the ABO grouping system is A and B. Now, just write presence or absence of either or both of them gives a blood group. Presence or absence of either or both of them. Presence or absence of either or both of them gives a blood group according to the ABO system. Are you guys done with that? Can you get? I said presence or absence. Presence or absence of either or both of the antigens gives a blood group according to the ABO grouping system. Is that clear? Should I repeat it? Should I repeat it? Can you guys still hear me? Hello? Why is my internet this shit? Can you guys see? Are you there? Okay, so we've written that, right? I can move ahead, right? Okay, now, having stated that, the next thing that you are going to write is that antigens can also be referred to as agglutinogens. Antigens can also be referred to as agglutinogens. Antigens can also be referred to as agglutinogens. Agglutinogens. Are you there? Agglutinogens. Now, having said that, you write that these antigens are located on the red blood cells. These antigens are located in the red blood cells. These antigens are located in the red blood cells. These antigens are located in the red blood cells. Are you there? Okay, full stop. Now, for every antigen present, or absent, there is a contrasting antibody in the blood serum. For every antigen present, there is a contrasting antibody in the blood serum. Antibody in the blood serum. Okay. So now, do you all know what the blood okay, the blood serum basically is just like the plasma. The only difference is that the blood serum does not contain fibrinogen. What did I say is the difference between the blood plasma and the blood serum? Okay, I've discussed the blood plasma, have I? Yes, so good. So we have that the total blood is made up of 55% of blood plasma, and this 55% of blood plasma has mostly water, about 91 to 92% water. Then you have blood proteins and the rest of them. So plasma has water, dissolved protein, and all those things, but serum is just plasma without fibrinogen. You can put that down. Serum is plasma without fibrinogen. Serum, SER, is plasma without fibrinogen. The major reason is because the fibrinogen is actually utilized for blood clotting. I have discussed blood clotting. I guess you guys were in that class. Were you in the class where I discussed blood clotting? Okay, so if you were in that class, in the ABO grouping, I gave something. I said the two grouping systems are ABO, and if you have an ABO, it is dependent on the presence or absence of A, antigen A or antigen B. So with that said, I now mentioned that if you have a particular, if I put this down, write it like this, note, if an antigen is present, if an antigen is present, a contrasting antibody, a contrasting antibody. Another name for antibody is agglutinin. Yeah, another name for antibody is agglutinin. Another name for antibody is what? Agglutinin. I hope this is clear. Okay, so what is the other name for antigen? Agglutinogen. Agglutinin. Okay, thank you. Now let's continue. So I said if a particular antigen is present, a contrasting antibody is present in the blood serum. A contrasting antibody is present in the blood serum. Are you there? Okay, good. Now I'm going to put up a table. You will help me fill up this table. Recipient, donor, because we are going to talk about agglutination. Okay, so just to help us understand this, okay, you could just write, just to help you understand it. Therefore, if a blood cell has let's start with that. Number one has, you could put like column or something. If a blood cell has antigen A, are you there?
Yes, sir.
The blood serum will have antibody what? Who can tell me? The blood serum will have what? Antibody. Contrasting now. Do you know what contrasting is? Opposite. So see A and B as opposite. So if the antigen A is in the blood cell, the blood serum will have antibody what? B. Do you understand? Hello? I can't. Can you guys hear me?
Yes, sir.
Please, I hope you guys are not distracted, because understanding this thing is sometimes confusing. So let's take it again. If a blood cell has antigen A, the blood serum will have what antibody? Antibody B. Is this clear? Okay, now this indicates blood group A or AO. This indicates blood group. This indicates blood group A or AO. This indicates blood group A or AO. So what I want you to write as a note after writing that statement is that the antigen of the blood cell determines the blood group. The antigen of the blood cell determines the blood group. The antigens of the blood cells determine the blood group. The antigen of the blood cell determines the blood group. Is this fully understood? So because we have antigen A, that's why it's in blood group A. Does anybody have a question? Does anybody have a question? Okay, now I'm going to give you guys a hereditary related question. Can you please listen? A question related to hereditary. For instance, if you see a question and they tell you that two parents with blood groups AO, are you listening? Two parents with blood groups AO and OO had a child with the blood group AB. So the question I have for you is there infidelity in that home? You know what infidelity is? Is this child their child? This is the father. This is the mother. And a child, one of their children, is claiming or has the blood group AB. Please, is there infidelity in the home, or is this their child? Are they the parents of this child? They are not. Okay, so let's find out the likely blood group their children can have. So their first child might likely have A and O. It doesn't work in that order. It's random. And that's what we refer to as the law of independent assortment. But we're not going to discuss that in this class. Okay, so the second person would have AO, then OO, then OO. So the only way they can have a child like this is this. Now, do you know that it is practically impossible, for this woman to give birth to AB? Do you understand? So what likely happened in the hospital is that they exchanged her baby for somebody else. Do you guys get? Because as OO, even if you bond with AB, you will get children of AO and BO. Even if you do BB, you have BO, but you will never have AB from a mother of OO. Sorry, what I'm saying, is it making sense now? So what happened in that hospital is that they exchanged the child. So the implication is that blood grouping can be used to some extent to determine paternity, but it's not entirely accurate. Do you understand? It's not entirely accurate. What is used to get it accurately is the DNA testing and stuff. So basically that. But then this is just one of the questions that I've come across in JAM. You get. So that's that basically. Now let's come back to what we are saying. So with that said, we go to the second scenario. So remember that the statements we made, can you refer to that statement again? If the blood cell, the statement before number one, what's the statement before number one? If the blood cell contains, can you read that statement please? I can't, nobody has that note. Okay, so if the blood cell has, okay, then number two, antigen B, then what will happen to the blood serum? The blood serum will contain, thank you very much, antibody. Good. Now, this indicates what blood group? Blood group B or BO. Good. Thank you. So if you are considering it, yeah, correct, yeah. So if you are considering it phenotypically, like trying to get the individual genes in them is B and not the, okay. So then we have the third one. If it contains, let's say no, what if it contains both antigen A and antigen B? The blood serum will have what? Yes, the blood serum will have, what antibodies will it have? And remember, the antigens there are A and B. So if A and B are both in the cell, what antibodies will they contain? They will have they will have no antibodies. Remember, once an antigen is, listen, once an antibody is present, once an antigen is present in the cell, the opposite antibody will be there. Are you getting what I'm saying? But if the two of them are there, and you have antibody A and B, it will start fighting this thing. So, because the two antigens are there will be no antibodies. Do you guys get what I'm saying? Thank you. So antibodies fight, which means if I have antigen B, I will have something that is fighting A. So now that I have antigen A and antigen B, it means that I will not have anything fighting any one of them. I hope this is clear. Now the fourth scenario is if the blood cell has neither antigen. Oh, sorry, what blood group is this? This indicates what blood group? Thank you. Blood group O, good. Meaning nothing. O or O. Good. Hope what I'm saying is making sense to you guys. Okay, then what if it contains neither antigens? Hey, no, what did we just say? This is not O now. It's AB. It's not O, it's AB. You remember that I said in your note that the antigens in the blood cell is what determines the blood group. Sorry, did you guys get? Hello? Check your, yeah, look at the note. I gave a note before number 2. Can you read that note? I did not, no. I said the note. Thank you. So if the antigen is B, it will be blood group B. But if the antigens are A and B, what will it become? Blood group what? AB. Sorry, excuse me. Excuse me, is this clear? Oh, you said AB initially. I didn't hear you sincerely. Okay, it's AB now. Huh? Huh? Oh, I have taught this thing before. Somebody eventually agrees. Okay. Oh, Precious just... Oh, Precious just stepped in. It's all right. She wasn't in class initially. Well, for the sake of, don't worry, let's just continue. So, when you have neither antigens, please do not miss classes. I'm not going to be doing this thing where, because you are not in class, I have to now repeat a study I've done. It doesn't make sense. I'm not going to be doing that with you guys because we have a lot. Yes, thank you. It's only Precious that was in class and some other people. Precious. Is Precious in class? Hello? Precious. Have I lost connection? Can you guys still... Can... Okay. Okay, let's continue. I thought I lost connection. Oh yeah, so... Yeah, the rest of you, did you understand? Besides Precious. You guys know why it's AB, right? Okay, let's continue. Okay, very good. So, I said, let's go to the fourth one. If it contains neither antigens A nor B, what would the blood serum contain? Yes, I'm asking a question. They don't have antigen A, they don't have antigen B. So what would the blood serum contain? What antibodies would they contain? They will not contain they don't have antigens, which means they will have antibodies. Do you understand? If there is an absence of an antigen, it would be the presence of that corresponding antibody. So now that they don't have antigens, it means that they will have both antibodies A and antibodies B. Is it confusing? Okay, so let's continue. I was saying something initially. Let's do this quickly, please. This is not the important part, but if you understand this, it will help us when we get to those important parts. So, neither antigens A nor B means that there is no antigen, which means there will now be the two antibodies. Here, they were the two antigens, no antibodies, which means now that we have both antigens, now that we have no antigens, there will be the two antibodies. Sorry, do you guys get it? Okay, let's take it again. If you noticed here, we have both antigen A and B. The implication is that there will be no antibodies. But when we don't have no antigens, you know, when I say neither means no, right? So antigens A is not there, antigens B is not there. It means that the two antibodies will now be present in the blood serum. Does it make sense to you? Okay, so that's that. Now, what blood group? Remember, the blood group is dependent on the antigens present or absent. So this indicates what blood group? What? I didn't get you. Blood group what? Exactly. So it indicates blood group O, or you say O. Correct. So that's that. I'm sure this is clear, so we can move ahead. Done? I want to move ahead. Are you done writing?